Let's talk about ionizing radiation. For this page, I'll want you to do it by yourself. Once again, there are two things that I can let you do. First, you may want to read the textbook, these two pages, and I'll put two videos in the description. So one will be this one, basically telling you that the three kind of radiation and the history of how we find it out. And apparently one is called alpha, the second kind is called beta, and the third kind is called gamma. Okay, so try to read, and then that would tell you the hints of doing this table mainly. And also this is just an animation, right? So I want you I want to show you the real stuff, which apparently as a school, even though we are having online class, even at the actual school, we don't have radioactive source because we did not license to purchase it, and of course we can't actually use it. So anyway, the only way that I can show you is by looking at this one. I hope you can, through this you can understand more about the properties of these three ionizing radiation. And by the way, the machine that he using here, you can see here, is called GM counter. We'll talk about later on. GM counter, Gauger-Müller counter, which is something to detect the radiation. Okay, so try to pause the video now, do it first, and continue the video to check the answer. Okay, so here's the answer. So first of all, for the symbol alpha, beta, gamma, I'll try to demonstrate once again on how to draw them. So first of all, for alpha, is simply like this. Alright, you can search online. For beta, it's not exactly B, but it's a Greek letter for B. So the way to draw it is more like this. And for gamma, be careful, this is not owl. Okay, not owl. Is the way to draw it is more like this. Alright, there must be a loop here. Okay, to draw this symbol. Okay, so here what I ask you is what are they exactly? That means in nature what they are, because in the past people named them alpha, beta, gamma because they did not know what they are exactly, so they just give them names. So just like when you do a math question, you give a certain number as x because you don't know what x is, so you name them x. Later on, if you heard from the video, then you see that alpha is actually helium nucleus. Be careful with what I'm trying to say here. It is nucleus, not atom. What's the difference? Think about it. What's the difference? The difference is for atom, it includes electron as well. So for alpha particle, if you know or if you have read just now, it is charged with 2+. So it's actually really helium nucleus instead, because for helium atom, which consists of the electron, it will be neutral by its nature. Okay, so it is not helium atom, it's helium nucleus, so that it is 2+, because of the proton, of course. The second one is beta, and in itself is electron, so you know for the charge it is -1. For gamma ray is we can't really talk much. It's really just gamma ray, okay, or we may call in general that is one thing in EM wave. If you remember in optics chapter 7, you learn about EM wave spectrum, starting from radio wave, microwave, etc. Okay, so the one with the highest frequency is gamma wave. Some people may like, if you study in IB physics, then we will talk about for light in general. We can also treat them as something called photon. Okay, but then I don't think you need it in IGCSE. So let's just keep it as gamma ray, and that is the highest frequency in EM wave spectrum. For the table, okay, let's talk about the table. You can see the symbols. I hope you don't mix it up. So highest on the right. For the charge, as we said, positive is 2+, beta is 1 negative. I recommend you to write it down on your notes as well. And for gamma, it is 0. So apparently, if we are trying to talk about the absolute relative charge, then that will be the sequence that I'm like it will be sensible. Some of you may try to argue that hey, -1 is actually smaller than 0, so should we swap these two? I think from a more physics perspective, I think the table, of course, I mean in exam they won't ask you like exactly like this, but I think the idea of here is trying to show you that beta, it has a charge, where gamma, they have no charge simply. Okay, so when you talk about later on when it's getting affected by the B field, then that will be helpful. Number 2, about the mass. So as you know, alpha is helium nucleus, and so they have 2 proton and 2 neutron. Maybe I'll write down 2 neutron and 2 proton. This basically is an alpha particle. For beta, it's just an electron, and for gamma, it's just a gamma ray. Okay, so actually I should draw a wave like this actually, but it's very hard to see. So for alpha, is much heavier than, of course, 1 single electron, so that would be maybe like 6,000 times maybe greater than beta. And the worst case is actually gamma, because gamma again is light basically, so they have 0 mass. For the speed, is basically the opposite of the mass, because for gamma it's an EM wave, so it travels in the speed of light. You may want to write next to it speed of light, and that is 3 times 10 to the power of 8 meter per second. For beta, as I remember, it will be around 0.1 C, I think, and then for alpha is much slower. So that's it, because simply they are, you may think that is because they are heavier, so it will move slower. Ionizing effect. Ionizing effect actually means, like, if you don't actually know what it means by the word ionizing, ionizing actually means ripping off the electron from a certain object or surface. For example, if you put alpha particle or alpha source, something that emits alpha, near your skin, this would not be a very good idea, because it will ionize your skin, and that basically damage your skin cell in that case. So if you heard about Chernobyl, which is a very serious disaster in Ukraine, or another very famous incident would be Fukushima in Japan, then the leakage of the ionizing waste, radioactive waste, is going to be very dangerous, because of its ionizing effect is so strong. So people getting in, their health will be in danger. So here we have alpha to be the strongest, beta will be the second, and gamma will be the weakest. So for gamma, actually, if you receive some dose of gamma ray, is actually okay. On the other hand, the penetrating effect is in fact opposite. You can imagine that all these three, they have limited energy when they try to ionize something. So what happens is alpha, it can ionize heavily, but then it cannot travel for too long, because in a short distance, alpha will already try to ionize so much thing that it cannot go for far. So you can imagine it's a 100-meter runner, so it can run very quickly. Not actually very quickly, it's more about the distance is very short, but then the burst of energy is high in the rate. But for gamma, it's like a long runner, like a marathon runner. It can run for long, but then the speed, again, I shouldn't say the speed, because speed is actually the fastest. But then I should say the energy in itself is gradually giving out, but in a very slow rate compared to alpha. So beta is like in the middle. Lastly, when we talk about the effects of deflection by the B field, and that is something you have to again consider by thinking about its charge, actually at the same time the mass as well. So you may want to relate these two, because when you move something, it's something to do with the force and something to do with the mass as well, because F equals to ma, right? So the effect is A, but then you have to look at the force, which related to the charge, and also its mass also. So you may find in all these rows, beta is in the middle, basically, and alpha or gamma is either on the two sides. But for this one, it's a bit different. Alpha is in the middle. Beta actually has the strongest deflection effect. Then you may say, hey, how come beta only have one negative while alpha has two positive, right? The answer is because beta has a much smaller mass. So the mass of beta is much smaller than the alpha. As I said, alpha has 4 nucleons. So 1 nucleon is like 1,800 times of the mass of the electron, not to mention 4 of them. So no matter that you have, one more charge for alpha, is still not enough to make up for the difference in terms of the mass. So therefore, the effect for beta deflecting in B field is much stronger. So that means the curvature will be much greater than alpha. And for gamma, actually there is no effect at all, and that is again because of its nature, that they have no charge, so they won't deflect. If you're okay with this, I'll want you to try page 5. Pause the video now and we'll check the answers later. Okay, let's take a look of the answer. So for this question, the question tells you that there are 3 kind of ionizing radiation, alpha, beta, and gamma, and then you have to identify them basically, and they are undergoing a certain magnetic field set. That's why they would turn. So the first answer that I think is a no-brainer, that is gamma, because it goes straight. As we said, gamma does not deflect or does not do anything with B field, so this is gamma for sure. And then for alpha and beta, the answer is this one, and the reason once again is because beta would deflect much more than alpha, so alpha would deflect not as much. Okay, so this is the reason why we find out this is alpha and this is beta. Part B is asking you the direction of the B field, magnetic field. So notice that we actually didn't know it. Only after we find out this is alpha and this is beta, then we can define or decide what B field it is. Okay, so that is something related to what you learned in chapter 9. Using the left hand rule or right hand rule. So I give you a second, you may want to pause the video, think about should you use left hand rule or right hand rule. Okay, so the answer, if you forgot like how to recall left hand side, left hand or right hand, is think about this. There's a way I told you how to remember. Left hand is actually like L is left and R is right. Left hand is actually something called for motor, and right hand is for generator. Okay, and then I think I told you in the class that how to remember how to link the word left to motor, R to generator, so I'm not going to repeat again. So in our case here, it's a case of motor, because you have current, all right, because of the movement of the charged particle. Yes, it has movement in itself, so there is current, and then the charge will get pushed because of the B field, and then you create the force, and that is same as the motor. You give electricity, which is current, to it, and then it will give a force to the motor. Okay, so here we simply would just need to pick one of them, alpha or beta. It doesn't really matter which one you pick. For simplicity, I will pick alpha, because alpha is positive, and two positive, and positive is the direction of current. If you remember, for beta, which is negative, and for conventional current, it will be opposite direction. So I would pick alpha for simplicity. Okay, so I can't show you my hand here, but I just try to show by drawing. So from this diagram, you can see that current, because of the alpha, you can see it was going up, so current is going up. And for the movement, FBI, right, F is actually to the left, so F is like this. So if you take out your left hand, FBI is up, F is going to the left, and so FBB will be going inside, okay, going in. So you may say the direction is into the paper. Okay, so yeah, that would be the answer.